pabrik bambu, tempat tinggal kita tanpa hiasan, tanpa lukisan. Beratap jerami, beralaskan tanah, namun semua ini punya kita. Memang semua ini milik kita sendiri.
Hey everybody, welcome back to Organic Chemistry. In this video, I'm going to go over the problem solving that I assigned for the NMR spectrums. So this is the wrap-up video. This is the last video for this chapter. And what we're going to do is, actually the way I'm going to approach this is, I didn't solve the problems yet. I didn't even look at them because I want to try to approach it for the first time with you guys. And so this way you're going to get, my approach. So this could either backfire, or it might work great, or it might not. In the past, I've done things like this and it works fine. But I think that for NMR, it's best for me not to have solved it before I do it on video, so that this way, together, we can actually approach the problem and kind of analyze the way things are working. Okay? So this is the last video set for this chapter. And then after this, I'm going to do the workshops that are related to NMR. Okay, so let's get started. Now, these are the problems that we're going to do. Handout number 23 through 25, and then Solomon 10th edition, question number 39, D through K. And again, if you have an older edition, it's definitely in the same chapter. It's at the end, and you'll see a whole bunch of questions, as we'll see in a moment. Now, before we begin, I just want to mention that this is the chart that I'm going to refer to, and you should probably print this out. I'll keep it clean so that you have a clean print. Actually, I'm sorry, I put up a clean copy on the website so you can see it. But yeah, so you should print this out because I'm not going to refer back to this. I'm probably just going to talk about it, and I'm assuming that you have this chart in front of you. This chart is not as necessary. I just figured in case there's a problem that requires this, this type of analysis, I'll come back here if I need it. And finally, this is the IR chart. And again, this is something that you should have from your textbook. And I'm not sure how much we're going to need it. But like I said, I haven't seen these problems. I didn't look at them. And so, it's beyond me whether I know if we're going to need it or not. The only thing that you should know is at least this up here. This is a good, useful little summary. And I gave this to you back in the exam when we learned about this material. This kind of gives you a general overview. Okay? So at a minimum, you should have this little diagram in front of you, and I don't think we'll need all this information down here. Okay, let's get started. So the first problem, it says identify isomers C and D, and the molecular formula is C4H8O2. So let's do a quick IHD. Actually, let me just analyze the rest. So here it's 1700. Remember, anywhere from 16 to 1800 is a C double bond O, right? So if we go back right here, anywhere from 16 to 1800, C double bond O. It could be a C double bond N or C double bond C, but the fact that I see an oxygen, it's probably going to be the C double bond O, right? But the one thing I do note here is that I see two oxygens, and I only see an IR of 1700. So there's nothing in the 3000 range, right? Which would be the OH. So this is not a carboxylic acid. That is my guess, because if it was, we would have an IR to support an OH at the 3000 range, right? So this must be like an ester or an ether and a carbonyl, one of those two. Probably an ester, if I had to guess, but we don't know yet, so let's take a look. C4H8O2. So let's do a quick IHD. C4H8. Now, if we had an alkane, it would be C4H10. We're subtracting those out. Remember, for the oxygen with IHD, we just ignore O, right? That's what we were told when we did IHD review. You just ignore the oxygen. It has nothing to do with the H count. So minus is subtracting out is -2 is 2, divided by 2 equals 1. So we have one IHD. That means it could be a double bond or a ring, and we already know it's a double bond, right? It's a double bond O. So that's what the 1700 tells us. So at this point, I know I have a carbonyl, but I also know that there's no rings and there's no alkene in the system, right? So there's no ring and there's no alkene, because we already know we have a C double bond O, and that's what gives us that one IHD. All right. So now look over here. So I guess what we could do next is maybe integration. And as you see here 23, 29. Well, you just have to divide everything by 10 in this case, right? So you get it to 3, 2.9, 2.3. So actually, what this is remember, this is our ratio stuff that we talked about, the integration numbers. And so you have to kind of, whatever you divide one by, divide the rest by. And so I'm going to bring this down by I'm going to divide it by 10 in order to get this to a 2.3, because that's closer to the number of H's. Remember the rule. When you have a number of H's given, then these right here have to add up to that number, right? So obviously 23 is big, and that's why I'm going to divide it by 10. So if I just divide this by 10, divide that by 10, and that one by 10, now we have 2.3, 2.9, and 3.0. And even further, we could round, right? So we could just round this up, or this one down. I'll round this up. So I'm guessing that this is really, and this is just like a rough approximation, but if it adds up, then we're right. I'm guessing that this is a 3 instead of 2.9, right? So divide by 10, you get 2.3. But then I'm going to just say, all right, forget the 3, just 2. And now let's see if we're right. So this right here, we could just say is 3. And so we have 3, 6, 8, and that's how many H's we're supposed to have. So I know now that I've figured out my H count for each chemical shift. Now, let me point out a few important details as I'm looking at this. The first one is that this right here is a blow up of this chemical shift. So our chemical shift is here, here, and here. Whatever else is above, if it's above the chart, that means it's a blow up of that right there. Okay? So this one, they don't give us a blow up because it's a singlet. But this is a quartet and this is a triplet. All right, so hopefully all this is making sense. And again, if you see a big number like 20 or 30, just divide it by 10 and you're probably right. And that's, basically how that would work. Okay. Okay, so that's what I would suggest, okay? Just divide it by 10. And again, you could always round, right? This is close to 3 and this is close to 2. So if it was 2.5, then it's on the fence. And then I'd work this out and figure out how many H's. If there's an extra H, I'd add it here, and if it wasn't, I'd subtract it. So I think that's kind of clear. All right. Now, what else can we get from this? Well, we know now that this right here is a CH3, right? This is a CH3, and this is a CH2. And I think that's about all we really need. And for this problem, I'm analyzing, and here's what I'm saying to myself. Let me tell you what I'm thinking. I've done pretty much the basics. I've got my IHD. I realize there's no fancy stuff going on. Double bond ring. It's right here. It's clear, right? And I know I have 4 carbons. I already figured out from this that I have these groups here by just, working with the integration numbers, right? I'm not even looking at the splitting yet. I don't care about that because I have so much information ready to get started. I have a carbon, 4 carbons, and 3 of them are taken care of here. And actually, I know the 4th is that. And I also know it's not an aldehyde, right? So maybe that's something. So let's do a quick, is it aldehyde? And the answer is no. I'm saying this in my mind because there's nothing over here. It's not even going at 10 to 12. It stops at 8. So there's no aldehyde, right? The answer is no. So, it makes sense that this carbon is in the middle, so it doesn't have any H's. So we already have our 4 carbons right here. We have 4 carbons in our formula, and I see the 4 carbons: methyl, methyl, methylene, and carbonyl, ketone, right? Or ester. Okay, so let's go ahead and start putting this together. So I'm going to start, as always, I always start with the functional group that's of importance, and that would be my carbonyl. And I know that this has a carbon on both ends. Now, actually, it doesn't have to be a carbon. It could be an oxygen. But right now, I'm just going to assume for sure that it's connected to something on both ends. It can't be an aldehyde, right? It might not be a carbon. It might be an oxygen. We don't know yet. But let's take a look and figure out what we can do from this. Well, I have a CH2, and I have 2 CH3s. And I also have an oxygen, right? That's my pieces. I have 2 oxygens. I already have one handle right here. Now, notice how you have a split over here. This is a quartet. This is a triplet. And this right here is a singlet, right? So this tells me that there's one methyl that's completely by itself. You see that? Because if it wasn't, meaning it doesn't have any neighbor H's. So this right here is an interesting peak for me because that would tell me that I have a methyl by itself, and it could be like this. It might be with the oxygens here, but I don't think so, and I'll tell you why. Because you see how the singlet's not furthest downfield? Well, this right here represents something that's closest to the oxygen, right? Remember, I showed you guys how if you look downfield, that's going to be closest to oxygen, right? So the fact that I have a singlet right here in the middle of the chart, not at the end, tells me that this oxygen is not near it. Because if it was, it would be furthest downfield, right? So if there was an oxygen over here, then this reading would be the furthest to the left. And that's not the case. So now I know for sure that this is right, because this methyl's by itself. I don't want to put a carbon here or it's split. And now let's think about what we have left. Well, we've got this done, but we still have these two, and they're coupled. You can see that, right? This is a quartet and this is a triplet. So they're splitting each other. And you say, well, how do I know that? Well, n minus 1 here is 3, right? 1, 2, 3, 4 minus 1 is 3. And notice how that's a CH3? And here it's n minus 1 would be 2, right? You minus out one of these lines, you get 2. So that means the neighbor is a CH2, and that's right there. So I know these two are neighbors, and I also know that they're splitting each other, and now I'm ready to solve the problem. Because if I had an O here, and then a CH3, these two would not split each other, right? This right here are now separated so they don't split. And in my chart, it's telling me that they split each other. So let's go ahead and erase that. That doesn't make sense. But what if we put the O here and then a CH2, CH3? Well, that's definitely the right answer because these two will split. And now let's think about this. Let's label it out. This is definitely A, right? It's the furthest downfield because it's further away from the oxygen here. So this one here is on a carbonyl, which isn't good. This one is on an oxygen, even worse, right? Remember our chart? If we go back to our chart,
we used to think when we are younger, leaving the lies behind the wall. Then she asked me what I'm thinking, and I said, oh, nothing at all. We're not a vintage generation. It's time to leave and break the wall. Then she asked me what I'm doing, so I said, now it's time for revolution. No, 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 you don't know me anymore. Low, low.
Rebot, pe!
When we are younger.